Hello everyone, good afternoon to everyone. Today I'll be taking you through a quick revision on 3 chapters. So we'll be discussing some questions basing on 3 chapters, which are, the first one is expressions using letter numbers, and the second one will be parity and intersecting lines. So we'll see questions basing on parity and intersecting lines, and the third chapter will be the number play. All right, so these are the 3 chapters which we are going to revise just quickly, and we are not going to discuss every single question because these chapters are very lengthy. So without delay, let us get started. We have the first question, which says one angle at the intersection of 2 straight lines measures 110. What will be the measure of the angle directly opposite to it? So you have one line going that way and another line going this way. They are meeting at this point, and this point here is known as the point of intersection of the 2 lines. So when 2 lines intersect at a point, they form a total of 4 angles. The first angle, the second angle, the third angle, and the 4th angle. Total 4 angles. Now, if one of these 4 angles at the point of intersection of these 2 straight lines measure 110, let us say this angle is 110. The question will be, what will be the measure? What will be the measure of the angle directly opposite to it? So if this angle is 110, even this angle will be 110. So the measure of the angle that is directly opposite to it will be 110. So what will be the correct option? The correct option will be option B. And you write here option B and the sentence that define option B. So it is option B, 110. All right? So you're done. The next question says, when 2 straight roads, you have 2 straight roads, cross each other, several angles are formed at the crossing point. How many angles are formed altogether? So like is how I said, suppose this is the first road, this is road 1, and this is road 2. When they cross each other, they form a total of 4 angles. They form a total of 4 angles. So the correct answer here is option C, and the sentence that defines that option, you have to write it. So when 2 straight roads cross each other, several angles are formed at the crossing. How many angles are formed altogether? So 4 angles will be there. Option C. And you write option C and the sentence that defines option C. The next question. 2 neighboring angles together form a straight line. 2 neighboring. Neighboring, in other words, is known as adjacent. So two adjacent angles together form a straight line. The question is, what is such a pair of angles called? I repeat, question 3. Two neighboring angles together form a straight line. So draw a straight line like that. So if you want to draw two angles which are adjacent to each other in such a way that they form a straight line, so simply keep a point somewhere here and then draw another line. Can you see that there are two angles here? Now, this angle you see here and this angle you see here, both of these angles are known as linear pairs. So, two neighboring angles together form a straight line. What is such a pair of angles called? So, the pair is called a linear pair. And the correct answer is option C. And you write the sentence that defines it. So, linear pair. The next question. A large rectangular hall is paved with 9,847 rows and 12,359 columns. And these are of identical square tiles. So we have a large rectangular hall is paved with 9,847 rows and 12,359 columns of identical square tiles. The question is, determine whether the total number of tiles is odd or even. So, we want to find the total number of tiles, but we don't have to calculate it. So, what you're supposed to do is this. A large rectangular hall is paved with 9,847 rows. So, 9,847 rows. And 12,359 columns. How do we determine whether the total number of tiles is odd or even? So here, total number of tiles, you take the number of rows, which is 9,847, into 12,359. You are not supposed to calculate this because the question is determining whether the total number of tiles is odd or even. So what you are supposed to do is to find out what is the parity of this number. Is this number here odd or even? Likewise, is this number odd or even? How do we determine if this number is odd? Look at the last digit. The last digit is 7, and therefore the whole number will be odd. Likewise, look at the last digit here is odd. Now, what is odd into odd? The answer is odd. So that means odd into odd gives you odd. So, to determine whether the total number of tiles is odd or even, simply don't multiply this calculation here. Simply determine if this number here is odd and if this number is odd. Simply look at the digit in the end. If the digit in the end is an odd digit, then the whole number becomes odd. And here, if the digit in the end, if the last digit here is odd, automatically the whole number becomes odd. And what is odd into odd? Odd into odd is odd. So the answer is option A. So answer here is option A, and you write the sentence in front of it. The next question, question number 5. Now, question number 5 says that in mathematics, symbols like A, N, X, Y, O, anything, that can take different numerical values. Different means the number which keeps on changing. So in mathematics, symbols like A, O, N, O, X, O, Y, that can take different numerical values are known as variables. And the word variable means something that keeps on changing, or something that takes different values. So the correct option here is option B, and the sentence in front of it is variables. So in mathematics, symbols like A, O, N, O, X, O, Y, or anything that can take different numerical values are known as variables. Next question. A delivery service charges, I repeat, a delivery service charges a flat fee of 1,500 Tanzanian shilling to pick a package, and then 500 Tanzanian shilling for every kilometer traveled. What is the expression for the total cost for K kilometers traveled? So a delivery service charges a flat fee of 1,500 to pick up a package. And then, and means plus. And then 500 Tanzanian shilling for every kilometer traveled. What is the expression for the total cost for K kilometers? So you have to multiply here by K. So the expression will be 1,500 plus 500 into K, or you can write it as 1,500 plus 500 into K. You can just write it like that. And in that case, the correct option here for question number 6 will be option, this option here, option C. So here, you write the correct answer is option C, and the sentence that defines it is 1,500 plus 500 K. So that's the correct answer. The next question, which will be question number 7. In a number puzzle, a digit means one digit. And when I say digits, I mean 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are what we call digits. Now, a digit, one of these digits, we don't know it. So a digit is added to itself. Let us say the digit, because we don't know, and there are 10 of them. Let us say the digit is, say, R. Okay? So this digit R is added to itself twice to form a 2-digit sum. So this digit here, which is R, is added to itself twice. And the sum is having 2 digits. But the units digit, or the digit in the ones place, the digit in the units place or the digit in the ones place of the sum is the same as the single digit being added. So the sum is a 2-digit number, but the digit in the units place or in the ones place is the same as this digit here, which has been added to itself twice. But in this sum, the digit in the tens place is different. So this is ones and this is tens. Now, I repeat this question. In a number puzzle, a digit is added to itself twice. So let us say the digit is R, and that digit is getting added to itself twice. The unit digit of the sum is the same as the single digit being added. Now the question is, what must the tens digit be? Okay? So, we can arrange this vertically, that we have a single digit, which is R. It is getting added to itself twice. And it gives you the sum, which is a 2-digit number, but in the units place, the digit should be the same as the single digit that we are adding. But this digit here is different from all of these. Now the question is, can you figure out here what will be the value of W? Because this is, W is the digit which is in the tens place, and R is the digit which is in the units place. All right? So now, which digit will you choose? Will you choose, say, 0? Add to itself twice, and you end up getting a 2-digit number in such a way that the digit in the unit place should be the same as the single digit we are adding. Okay? So it can't be 0, it can't be 1, it can't be 2, it can't be 4, it cannot even be 3, but it will be 5. Let us see. A digit 5, add to itself twice. What do you see? 5 plus 5 plus 5, 15, carry 1. The one you carried, you keep it here. Can you see? In this 2-digit sum, the digit in the ones place is the same as this. So, the question is, what is the digit The question is, what is the digit in the tens place? So the digit in the tens place is 1. So the digit in the tens place is 1. So the correct option here is option D, and the sentence in front of it is 1. So the correct option is option D. Right? Now, the next question. Question 8. In a sequence where each term is the sum of the two preceding terms, and two consecutive numbers are 55 and 89. Can you find the next two numbers in the sequence? Can you also find the two numbers that came immediately before 55? Okay? So how will you do this? First of all, a type of a sequence whereby the next number is obtained by finding the sum of the two preceding terms. Such a sequence is known as Fibonacci sequence, or in other words, Virhanka sequence. Now, the two consecutive terms are 55 and 89. Can we figure out the next two numbers? Can we figure it out? Yes, we can. The next two numbers the next number is obtained by finding the sum of the two preceding terms. So for example, if I'm looking for this number here, I will take these two numbers, add them. I will take this number here, add it to this number. I will get this number. So how do we get this number? Simple. 55 plus 89. So when you do 55 plus 89, this is 14, carry 1, and this is 13, add 1, that is 14. So the next number is 144. Now, to get this next number, simply take 89, add it to 144. Add. So you have 144, add it to 89. What is the answer? So 144 added to 89, you have 13, carry 1. You have 12, add 1, 13, carry 1. And you will have 233. So the next number here is 233. So the next two numbers in the sequence are Roman 1. The next two numbers are the first one, 144, second one, 233. You are done. Next, can you find the two numbers that came immediately before 55? Well, this is Roman 2. The two consecutive numbers are 55, 89. So you have 55, you have 89. Now this time, you need to find the number that came before 55. Do the reverse. 89, subtract 55. So 89, subtract 55. So when you do 89, subtract 55, you have 4 here, you have 3. So the number that came immediately before 55 is 34. How do we figure out this number here? Simply do the reverse. 55 subtract 34. So when you do 55 minus 34, you will have 1 here, you will have 2 here. So the two numbers that came immediately before 55 are 21 and 34. So the two numbers just before 55 are first one 21, second one 34. That's all. So the two numbers that came immediately before 55 will be 21 and 34. Next question. Next question. Determine the 300th odd number in the sequence of odd numbers. First of all, you need to know what are those odd numbers, and later you can find the 300th odd number in the sequence of odd numbers. So what are the odd numbers? Odd numbers are 1, 3, 5, 7, 9, 11, and so on and so forth. So what do you have? From 1 to 3, we have add 2. 3 to 5, add 2. 5 to 7, add 2. 7 to 9, add 2. 9 to 11, add 2. So the sequence is adding 2 to get the next other numbers. Can we find the so-called nth term? Can we find the so-called nth term of odd numbers? Can we find the nth term? And later use the nth term to calculate the 300th odd number. Yes, we can find the nth term. How do we do that? Just look. This is the first number. This is the second number. This is the third number. This is the fourth number. This is the fifth number. And this is the sixth number. And so on. How were these numbers obtained? They depend on this number. Add 2, add 2, add 2, add 2. How do we do that? Take this, add 2, multiply it here. What is 2 into 1? The answer is 2. But we were hoping to get 1. But we did 2 into 1, we got 2 instead of 1. So 2 into 1 is 2. How do we get 1? You have to minus 1. Then take this 2 here, multiply it here. What is 2 into 2? 4. But we were hoping to get 3. But we got 2 into 2, we got 4. How do we get 3 out of 4? Minus 1. The next number, which is 5. Take this 2, multiply it here. You have 2 into 3, that is 6. But we are hoping to get 5, but we got 6. So 2 into 3 is 6. How do we get a 5 out of 6? You have to minus 1. So you can see minus 1, minus 1, minus 1. How about this one? How do we get 7? Take these 2 into 4. 2 into 4 is 8, but we were hoping to get 7, but we got 8. How do we get 7 out of 8? You have to minus 1. Likewise here, 2 into 5, this 2 here, into 5 is 10. How do we get 9 out of 10? You have to minus 1. Likewise, this will be the same thing. Into 2. 2 into 6 is 12. But we're expecting to have 11. How do we get 11 out of 12? You have to minus 1. Now, can we get the so-called nth term? Yes, we can. You'll do n into 2, which will be 2n, then minus 1. You can see here, we are minusing 1, we are minusing 1, we are minusing 1, we are minusing 1. So the nth term will be 2 into n minus 1. So your nth term for odd numbers will be 2 into n minus 1. Can we now use this formula to calculate the 300th term? Because that is the question. Determine the 300th term. Determine the 300th odd number in the sequence of odd numbers. So the moment we got the nth term, which is 2 into n minus 1, we can calculate the 300th term. Or we can calculate the 300th odd number, which in this case will be 2 into, in place of n, you're going to put 300. So 2 into 300, the answer you get, minus 1. What will be this equal to? That will be 600 minus 1. And the 300th odd number will be 599. That is your final answer. Now, the next question. The next question. In figure 5.27, give me a second. Give me a second. All right. So in figure 5.27, lines L, this line is line L and this line here is M, are intersected by the transversal T. This line and this line has been intersected by this transversal T. If angle A is 120, if this angle here is 120, and angle F is 70 degrees. Now the question comes, are these two lines here? This line here, L, and this line here, M. This line here is line M. Are these two lines, L and M, are they parallel to each other? Now, how do we know that the two lines are parallel? Now we say two lines are parallel if corresponding angles are equal, corresponding angles are equal, or alternate angles are equal, or co-interior angles add up to 180 degrees. So that is what you're supposed to check. I repeat, how do we determine if two lines are parallel or not? How do we do that? Two lines are parallel if corresponding angles are equal, or alternate angles are equal, or co-interior angles add up to 180 degrees. I will use this concept of co-interior angles to determine if line L and line M are parallel. I will use this concept, but you can use the concept of corresponding angles or the concept of alternate angles. Now, for co-interior angles, we look for letter C. For co-interior angles, we look for letter C. So let us get started. Now, if you clearly look at this angle, let me show you. This angle here is 120, but it is vertically opposite to this angle. And we say vertically opposite angles are equal. So if this angle is 120, even this angle is 120 degrees. Now look at this. Can you see something we call letter C? Can you see it? Can you see something we call letter C? Now, what do we say when we spot letter C? We say that co-interior angles add up to 180 degrees. Now, what are those co-interior angles? One is 120, another one is 70. If you take 120 and 70, add them together, do you get 180? If you don't get 180, therefore, you conclude by saying that the two lines are not parallel. But if you get the answer equal to 180, then the two lines are parallel. Okay, now let us see. 120, which is this angle, plus 70 degrees, you are getting something different from 180 degrees. You are getting 190. Now, how do we conclude that? We conclude by saying that since co-interior angles add up to 180 degrees, and in this case, we got 190 degrees instead of 180, this indicates that the two lines are not parallel. So we say that co-interior angles add up to 180 degrees. But what did we get? We got 190. Now, since co-interior angles add up to 190 degrees in this case. In this case. Therefore, lines L and M are not parallel. Are not parallel. Okay? Because we got 120 plus 70, which is in letter C. We got something which is not equal to 180. We got 190. Because of that, those lines L and M, this line L and M, these lines are not parallel. Okay? I think that is clear. So co-interior angles add up to 180. So since co-interior angles add up to 190 in this case, therefore lines L and M are not parallel. But if the answer was 180, then you could have said that those lines are parallel. But they are not parallel. The next question. Question number 11. Sarah has only even numbers. Sarah has only even number cards. She wants to choose exactly 3 cards and add them together to get a sum of 21. Using the rules of parity, which say, for example, even plus even equals to even, explain why it is impossible for her to reach an odd sum like 21. So, in this case, we are given 3 cards, and these 3 cards, and they are all even. So 3 cards which are even, is there a possibility of adding these 3 cards and end up reaching a sum of 21? And remember, 21 is an odd number. Is there a possibility? So let us see. 3 cards are there, and they are all even number cards. Now, since there are 3 cards, now let us see. The first even number, plus the second even number, plus the third even number. What do you get? Even plus even is even. When you add, again, even number, what does the parity say? Even plus even, answer is even. So this means that even plus even plus even, answer is even. But what do we get? We got a sum which is 21. But the sum of 21 is odd number. 21 is odd number. So that implies that it is impossible for Sarah to reach a total of 21 using only even number cards. So that implies that it is impossible for Sarah to reach a total of 21. To reach a total of 21 using only even number cards. It is impossible. Using only even number cards. Using only even number cards, it is impossible for Sarah to reach the sum of, or a total of 21. So that implies that it is impossible for Sarah to reach a total of 21 using only even number cards. Next question. Next question. Two parallel lines are cut by a third line. Two parallel lines. So just take a scale and draw those two parallel lines. So we have the first line like this and another line like this. Now these two lines are parallel. Now those two parallel lines are cut by a third line. Like this. If one angle formed, maybe this angle, if one angle formed is 65 degrees, calculate the remaining angles using appropriate angle properties. How many angles are remaining here? Who can guess? We have a total of 7 other angles. So we have to calculate them. The first angle, 1, 2, 3, 4, 5, 6, 7 angles. So we have to find them. How do we find them? First, let us do labeling. That is A, B, C, D, E, F, G. So we need to find what is angle A, what is angle B, what is angle C, what is angle D, what is angle E, what is angle F, and what is angle G. How many angles? 1, 2, 3, 4, 5, 6, 7. We have to find them. But we have to use appropriate angle properties. Do you know them? First one, linear pair property. Linear pair property. Can you see that? I can calculate A by using linear pair property. Angle A plus 65 equals 180 degrees. What is this? Linear pair property. Linear pair property. How do we move from here? A will be big number 180 minus small number 65. What is angle A? Angle A will be 115 degrees. So angle A will be 115 degrees. So here is 115 degrees. Can we get C? Yes, of course. If this angle is 115, also this angle will be 115 because vertically opposite angles are equal. So this is angle A, this is angle C. So angle A and angle C are equal. Why? Vertically opposite angles are equal. So angle A equals to angle C, angle property. Vertically opposite angles are equal. Vertically opposite angles are equal. So because we got angle A is 115, so even angle C will be 115. Okay? So this is 115. How about angle B? This is 65, also this will be 65 because vertically opposite angles are equal. So this is 65, B will be equal to 65. So you write angle B equals to 65 degrees. Why? Vertically opposite angles are equal. Vertically opposite angles are equal. Right? So we are done. This is also 65 degrees. Can we find angle D? Yes, we can. Look at this. Z. If this is 65, also this will be 65. Z. Can you see that? That is Z. Which suggests alternate angles are equal. So 65 here, D will be equal 65. So 65 here, also D will be 65 degrees. So here you're going to write angle D equals to 65 degrees, and the angle property is alternate angles are equal. Alternate angles are equal. See that? All right. Now, if this angle is 65, also this angle is 65. How about this angle? This is angle D. How about angle F? How about angle F? Vertically opposite angles are equal. So even angle F and this angle here are equal. So angle F will be equal to, angle F will be equal to 65 degrees. Reason, vertically opposite angles are equal. Vertically opposite angles are equal. So we are done. Here, 65, even this will be 65 degrees. Okay? Now, can we use linear pair for E? Yes, we can. Yes, we can. 65 plus angle E equals 180. 65 plus E equals 180 degrees. How do we get E? You take big number 180 minus small number 65. And E will be equal to 115 degrees. What is the property here? Linear pair property. Okay? So now we know that E is 115. Can we get G? Can we get angle G? So angle E we got 115. Can we get angle G? Yes, we can. This is 115. Also G will be equal to 115. How did I know? Vertically opposite angles are equal. So angle G will be equal to 115, and the reason will be vertically opposite angles are equal. Vertically opposite angles are equal. And that is all. Can you see? We have a total of 7 other angles here. 115, 65, 115. 115, 65, 115, 65. Right? So we have a total of 7 other angles. 1, 2, 3, 4, 5, 6, 7. Done. Now, the last question for today. The last question for today. Pay attention here. A mobile plan costs 5,000 Tanzanian shilling per month, plus 100 Tanzanian shilling for every minute used. Questions. Write an algebraic expression for the monthly bill if m minutes are used. The first question. A mobile plan costs 5,000 Tanzanian shilling plus 100 Tanzanian shilling for every into a certain number of minutes used, which is m. So write an algebraic expression. The algebraic expression will be 5,000 plus 100 into m, or 5,000 plus 100 into m. You can write m like this. So 5,000 plus 100 m, or 5,000 plus 100 into m. That will be your algebraic expression. Question 2. If a person uses 45 minutes, calculate his total bill. So we go back to the algebraic expression and then we find total bill. A person uses 45 minutes. Calculate his total bill. So in that case, M will be 45. So total bill will be 5,000 plus 100 into M. But in this case, M is 45 minutes. So we'll do 100 into 45 and calculate this. 5,000 plus 100 into 45 is 4500. When you add 5,000 plus 4,500, the answer will be 5,000 plus 4,500. Answer will be 0059 T shilling. This will be the total bill. All right? So bye-bye for today. Thank you very much for listening to me. All right. See you next time.